this point, you should have gone through the POGIL activity called the nuclear atom. And for me, this is in my chapter 2, pretty early in the year, all about the structure of things. Well, POGIL is, short for process-oriented guided inquiry learning. And the idea here is that we've been talking about guided inquiry labs, but you can also do activities in classes that are guided inquiry. And the idea here is that students are working in order to process information and come up with the knowledge themselves rather than just being told things. I want to see that this is going to affect how we present information, and sometimes it's really good in order to have the students figure out the concept first and then add vocabulary to that later. We'll see that in a minute. And one of the things that shows up in the new revised curriculum is this idea of claims and evidence, and we'll see that here, and we'll also see that in some of the revised curriculum standards for science and some of the other big standards-based ideas that are coming down the pipe. Now, you've already gone through these questions. So how many protons are found in carbon-12? So these are called models, these little pictures or something. And so how many protons? All we have to do is look at this and say, okay, there are 6 protons. So we'll say 6. And how many protons are in carbon-13? We also see there are 6 protons. And in carbon-13 with a minus charge, there are also 6 protons. Now, how many neutrons are in carbon-12? Well, it says right here that there are 6 of those. Okay, how many in carbon-13? There are 7 of those. And how about in carbon-13 with a minus charge? There are 7. How many electrons? Now, the electrons, we actually have to kind of go back and count. So we can see them out here. There's a little chart on this page that says these guys are electrons. So 1, 2, 3, 4, 5, 6. And this other one, 1, 2, 3, 4, 5, 6. And in the ion, there are 1, 2, 3, 4, 5, 6, 7. So based on the model, okay, what do all carbon atoms and ions have in common? Well, we can see that they all have 6 protons. Now, what do all hydrogen atoms have in common? So there's another picture with hydrogens, and we see that they all have 1 proton. Next idea. So what's the significance of the atomic number above each atomic symbol in the periodic chart? So you have to be getting out a periodic chart, like I took a little piece up here. And if we find carbon on the periodic table, we'll find out the little number above there is 6. If we look at hydrogen, the little number above is 1. So we can say, what's the significance of the atomic number Z? Okay, that's the number of protons. Now, what do all nickel atoms have in common? Okay, all nickel atoms are going to have 28 protons. And we can ask more. What about silver? All silver atoms are going to have 47 protons. All rhodium atoms have 45 protons. Now, what about the mass number? Is the left-hand superscript next to the atomic symbol. So we could see some examples here. That little left-hand number, that's a 1, that's a 2, and that's a 3. Okay, how is that determined? Well, it looks like the number of protons and the number of neutrons. We can test it out here with this picture. Okay, that's 16 because we have 8 protons and 8 neutrons. And this one here has 23, 11 protons, 12 neutrons. So that mass number A is the number of protons plus the number of neutrons. And we have enough examples on our page that we can actually test that hypothesis. So if we were discussing this, we could come up with that idea. Now, what structural feature is different in isotopes of a particular element? Okay, well here we have 3 isotopes of this element here, and we can see what's different. They all have 1 proton, but they have different numbers of neutrons. So different numbers of neutrons. Now, what feature distinguishes a neutral atom from an ion? So here we have a couple of ions, and in the full page we can see that we have some ions, or we went back when we had carbon, and we can see what's going on is that the number of protons equals the number of electrons in the neutral atom, and in the ion, okay, they're different. Number of protons does not equal the number of electrons. And if somebody were to say, you know, that there are more electrons or there are fewer electrons, well, then we have to go look at all these different examples that we have and find out that sometimes there's more electrons, sometimes there are fewer electrons. Now, how is the charge on an atom ion determined? Okay, well, the kids can work on that for a while, and if they work on it, they might find out that if you take the number of protons minus the number of electrons, that's going to end up giving you the charge. And they can come up with that idea as they go along. Now, the next question, where is the most of the mass of the atom? Within the nucleus or outside the nucleus? Explain your reasoning. Now, 9 times out of 10, when I ask that question, then the students will go, well, most of the mass of the atom is within the nucleus. And they say, why? It's just because it is. That's where the protons and neutrons are in the nucleus, and they are heavier than the electrons. The electrons are very light. Okay, very small mass there. So most of the mass of the atom is inside the nucleus. Now, that is absolutely true. Okay, most of the mass is in the nucleus, but the question here is, on this page, with all this information, all these models, how can you prove to me that the mass of the atom, most of the mass of the atom, is inside that nucleus? So we're going to look a little more closely. We have one little statement here. The nucleus of the atom contains the protons and the neutrons. So we established that. So the electrons are outside. Then, if we say, maybe look at this carbon 13 and carbon 13 minus, the only difference here is that here's one more electron. This has 7 electrons, this only has 6. So if we subtract their masses, so 13.0039 AMUs minus 13.0034 AMUs, then we can see that the mass of a electron must be about 0.0005 AMUs. Now, here we have hydrogen, and since we know that this is a proton and an electron, then a proton must have a mass of 1.0073 AMUs. And if we go back to, let's say, these two, we can see the only difference there is a neutron. So the difference in their mass must be the mass of a neutron. So a neutron must be 12 from 13.0034. So 1.0034 AMUs would be a neutron. So for any atom, since the nucleus contains the protons and the neutrons, and protons weigh a little bit more than 1 AMU, neutrons weigh a little bit more than 1 AMU, and electrons weigh 0.0005 AMUs, then we can say definitely that the mass, most of the mass of the atom is within the nucleus where we have the protons and neutrons. So you can see the total difference here is, in the old curriculum, there were a lot of times where we just asked students, to remember information like, where's the mass of the atom? It's in the nucleus. Okay, the newer curriculum is going to ask them to come up with, make a claim and back that up with evidence. And in this POGIL activity, you can see that you make the claim that the mass of the atom is in the nucleus, and you've got to have evidence to back this up. And we can see how we could use the information given on that page to get that evidence. So we've seen here that POGIL means process-oriented guided inquiry learning. So the idea is, as students work through that information, they are developing for themselves the concepts. Then, second thing, concept first, vocabulary later. We saw back in examples where students were coming up with the idea of what a mass number was and what the atomic number was, and before they even had those terms. And when we finally say, okay, this number represents the mass number, then they can say, oh, that's just the number of protons and neutrons. And we say the atomic number, that's the number of protons. And finally, this idea about claims and evidence, that you can make a claim and then you need to be able to back it up with evidence. Now, just for completeness, okay, number 11, if you fill that in, these are the answers to number 11 chart. I found this on the internet when I was looking for other things to make up this tutorial, and this is a Wordle, and so you just take a text and it turns it into all the different terms that might show up when you're talking about POGIL. Finally, if you check online, if you want to know more about POGIL, then you can check online, and just Googling POGIL, the first two things that come up for me here is something called POGIL Home and About POGIL. And if I was looking at this About POGIL, they have a place where you can watch a lady in her POGIL classroom, and you can see how these kind of activities happen. So again, these activities normally would be done where a student would work through several questions. So like on my, when I use this worksheet in my class, I just say, okay, do questions 1 through 4. And then you do that individually. Then you work with a small group. And as you work with a small group, you discuss your answers. And then as a class, we discuss the idea just to make sure everybody gets it. Then we go on and do some more and do some more. Flynn has just come up with a book. I think it's about $49. And he has activities for high school chemistry. I did purchase this myself, and I use several of the activities, especially early on, to help me with my building up skills about independent and dependent variables for labs. So what I've used so far I really liked. So that's what we have here about POGIL. Now, last thing is that this little tutorial is made with a iPad app called EduCreations, and it's a free app. You can use it with an iPad, or you can actually use it with your computer if you have like a little tablet so you can do your writing. And it's free. You can make these tutorials, and it's just a whiteboard sort of tutorial. Really handy. So that's all for this.